Hi, today we are going to discuss aldehydes and ketones. We have prepared already. Aldehyde also we know how to prepare now, and ketones also we know how to prepare. So today in this video we are going to react them. So we are looking into their chemical properties. The chemical reaction we will see, how they react with the different regions. So if you see the chemical reactions, they are nothing but electronic exchange. It is a game of electrons. The bonds breaking, there will be some bonds which will be breaking in reactants, and newly formed bonds will be created in products. That's what a chemical reaction is. So let's go. So the first reaction which we are going to do is aldol condensation. Note down here, ALD, what it can be? Aldehyde. What is OL? It stands for alcohol. So something, the product we will get, which will have aldehyde as well as alcohol. And a note on this word, condensation. What does that mean? Condensation simply means joining two molecules. So in this reaction, we'll be joining two molecules and we will getting aldol. That is what the main reaction will do. So let's see how it happens. Let's do step by step. So now I'm going to take two aldehyde molecules, which will be like 2CH3 and CHO. Okay, we can write it like this, CHO, or I can write it like this. Okay, so don't get confused why if I'm writing CHO, it is an aldehyde. So there are two molecules, and I'm going to react this with my reagent dilute NaOH. It's a base, and also note down its name NaOH, and it is a dilute. Both words will be important. That it is dilute, it has water, and it is NaOH, a base. So after this, what happens is we will get aldol. So let's do the first direct reaction. So it will be like CH3, this guy, okay, one of the molecule like this. Then they are going to condense or join together. We will get one OH here, all has come, and then CH2, CHO will be like that. So here it is aldehyde, CHOR, and here is ol or alcohol. That's why we will call this molecule which we have prepared as aldol. So we have condensed two aldehyde molecules in the presence of, with the use of, as a reagent of sodium hydroxide, dilute sodium hydroxide, and we have prepared aldol. What is the name of this? So we can call this, if you, this is a popular name, but we can also call that 3 hydroxy butanol. So the numbering will be given from aldehyde. We will give the priority to this. This should have the lower number. We will not start our counting from here. That's why the number is coming as 1, 2, 3 hydroxy butanol. Null stands for aldehyde. So remember that the numbering also, the technical name also, and the popular name also we should know. Now, what we will do is after this, we will remove water from this. So we will remove water from this. Aldol is prepared, but we can do the next step, which is very important step and which gives us very, very interesting structure. If we'll do this sign in a reaction, triangle kind of, it is like heating. So this represent heat. And if we heat something, what will evaporate is water. So we are doing minus H2O. Okay, so that's why we can say that we are removing water from aldol now. So what will happen? OH, okay, and one H from here will be evaporated, and these carbons will have a double bond now. So it will be something like this: CH3, CH, OH is gone. Taken one H from here also, it was CH2, CH2, one H is gone, and now CHO or aldehyde. So this structure will be called but. Why but? Count the carbons: 1, 2, 3, 4. 4, 2, enol. Okay, enol for are aldehyde. Okay, but why? Because they have four carbons. Why in? Why not A? Because in we use for double bond. So remember that why these words are coming from where these are coming. So this is coming due to double bond. This is coming because we have CHO aldehyde group. Okay, so that is how we name this. So let me revise. We took two molecules of aldehyde in the presence of a dilute NaOH. They react and they get condensed. Both molecules will be joined, so we will get 1, 2, 3, 4. join together, we are getting alcohol, and we are getting also the aldehyde. That's why we are naming it aldol. The technical name will be 3 hydroxy butanol, right? Butanol. This is U. Sorry, this is U. Butanol, right? 4. And why we are saying 3? Why not starting counting from here? Because we will always give lower number to the aldehyde. So this should get the lower number. 1, 2, 3. 3 hydroxy butanol. Al stand for the aldehyde. Now after that, we remove water by heating it, and we show it by this triangle. And then this OH is gone. One H of this is gone, and one double bond comes here in between, because carbon has can have 4 bonds only. So it will have 4 bonds here, and we will get but-2-enol. Now let's go to the slow motion. Let's see the action at very slow rate, understand how this action is happening, what is the mechanism of this reaction. So we had taken 2 molecules of aldehyde. I will write it first one here, and I will write it in detail. So I will not write simply CH3 CHO. I just wanted to show you the structure. So this is CH3, and this is the carbonyl carbon, right? This is the carbonyl carbon where the double bond of oxygen is. So if this is called carbonyl carbon, the carbon just next attached to this carbonyl carbon also have a name. We call this we call this alpha carbon. Also with this alpha carbon, the hydrogens are attached, and these are called alpha hydrogen. Yeah. So these are alpha hydrogen. So I'll repeat, carbonyl carbon, the next carbon bond which is attached to it has a name. We call it alpha carbon. And with this carbon, there are hydrogens. They'll be called alpha hydrogens. 1 alpha hydrogen, 2 alpha hydrogen, and 3 alpha hydrogen. So why I'm talking about this? Because these alpha hydrogen, these ones, have a property. They are acidic. They are acidic. It can be donated. H positive can be gone from here. So if you know this, now understand what our reagent was. It was sodium hydroxide. So if H positive can be gone from here, there is OH negative from NaOH which can do the reaction. So this guy will get together, form H2O, H and OH. Remember, this has come from NaOH. That's why I told that the regions are important and what they are doing. So the first molecule, the alpha hydrogen, is getting donated. H positive is getting donated here, joining with OH negative. And what will happen with this? This carbon will take this bond back. So it will become what? Right? H positive is gone. This bond is taken to the carbon, so it will become negative. So I will show what will be the future of it. HC negative, right? And here it is H, here it is double bond O and H. So as of now, what we have done, we have just done acidic alpha hydrogen has combined with hydroxide ion, and we can call this reaction is, remember, this is acid base reaction, right? Acid base reaction. So as if now the first step, acid base reaction has happened. This is acidic, this is basic, they have joined, and the acid base reaction has gone. The carbon has become negative. The alpha carbon has become negative. Now what can happen? What this negative charge will look for? It will look for a positive charge, a nucleus. So it will look for doing nucleophilic addition. So this is how step by step things are happening. Okay, where it can add, right? So we have another aldehyde group. So let me write that here. So that is CH3 CHO. So this negative charge, okay, will do a nucleophilic addition, because we know the structure of aldehydes. The carbon is electron deficient. It is polar. It is has positive charge. So this carbon negative can join here, right? So that's how the condensation or the joining is happening. Okay, but think about it. It already have 4 bonds, right? How it can join, right? Even if this carbon try to establish it, it will be 5 bonds, and that cannot happen. So what will happen? This oxygen will take this double bond, one of the bond, it to itself. So this will shift. So let me name it like, how it is happening. So this is the first step. It's trying to attack, and this is what the second step, which is happening. Oxygen is taking it back. So it will become negative. So let me write what happens next. So I need more space. Yeah. So after this nucleophilic addition, what will happen? So let me write this molecule, CH3, C. Now oxygen have single bond and have negative charge on it, okay? And this is H. And now this carbon will be below this, right? C. I can say CH2 CHO, just writing it in a short. So this is got attached. So this is what the nucleophilic addition happened with the other molecule. So the first step was acidic acid base reaction. Then the nucleophilic addition happened. They got condensed. If you see, they are joined now. Now what is the next step? The next step is I need to write this way because I'm running out of space. So now remember the NOH is dilute. Always whenever we are using acid or base, they'll be having water in it. So now this HOH or H2O will do its job. So the dilute word becomes important. So if you can see here, O, right? O. So this will be joined with this H. Okay, dilute NOH is working now. Okay, so this is water, nothing else, water. So this H will join here and O will get H. What we will get? Our alcohol. So that is what is happening. So let me write it the complete structure now. So we have CHC, C, and this is OH, right? OH. Then this is CH, and this is CH2, CHO. Yeah, and this is what where we are getting aldol. This H2O is also acid-base reaction. So remember the steps, like which kind of reactions are taking place. So first, here acid-base reaction happened, then nucleophilic addition happened, and then again the acid-base reaction happened. Now from aldol, we are going to remove water. Now we want to remove water from this. For that, I will explain you with a detailed structure how it is. So I just want to write like this as CH3, then this is ROH, and this H I want to show it downwards so that our CH2 CHO, they are same bond, so I can show it here also. So this will be like this CH2, then this is what the aldehyde group will look like, right? So the same way I am showing here, but now in the expansion so that you understand from where we are going to remove water. So after this, I will show, okay, delta heat minus H2O. So now for while we heat it, we need H2O. So this OH will be removed and this H will be removed. Okay, so H2O is gone. But now these carbon are lacking one bond. So they will bond with each other. They will establish this bond, right? So they will be double bonded now. So the result which we will get, I will show it only here. So it will be CH3. Okay, so I'm combining it and showing it like that. Now we have double bond, CH, double bond with CH, and then carbon, double bond, oxygen, hydrogen. Yeah, so that will happen. And now you will see there is a double bond here. And also please notice that there is a double bond also this. And this product which we have got is very stable, very stable. Okay, stability means it has low energy. Okay, so you can ask question that why these H2 is getting removed. What is the need of it? When we heating, they should be stuck here. What is the thing which we are getting so that they are doing this sacrifice or this elimination is happening? So remember what we have done is elimination. This reaction will be called elimination. So now why that is happening? Because the product or the result is very stable. Every molecule wants to be stable. And why this is stable? Look at this double bond. And one alternate another double bond is there. And this is called conjugation. Alternate pi bonds we are able to see. So our electrons, these pi electrons can delocalize, they can move around. And due to that, they will produce resonance, which increases the stability. Increases the stability. So what is conjugation? Double bond, single bond, double bond. That's what, right? If that happens, these pi electrons will are free to move. They will delocalize, and doing so, they create a resonance, and that increases the stability. And remember, stability is inversely proportional to energy. So if I'm increasing stability, I'm decreasing the energy. That way we can say. And if you want to now, because we have discussed this resonance again and again, conjugation, and why the stability is increasing. So let's define that also. Okay. In case of resonance, what is happening is the electron travel or you can say fancy word localize, get delocalized. They can move around within molecules, within molecules. So these double bonds, right? They are free to move here and there, right? And within a molecule, they can move around, right? Now, while moving around, what will happen? The force of attraction of nuclei, nuclei means a plural of nucleus, and pi electrons, because pi bond is only moving, pi electrons are only moving. Pi electrons increases. So if the strength increases, right, force of attraction between them increases, the stability increases. Stability increases. Now think about this, what I've said. So these pi electrons, they are free to move. So they will see different nuclei, this carbon's nuclei, this carbon nuclei, but they can be seen here also. With this carbon nuclei also, they will interact with. With this oxygen nucleus also they will do. So they will have many nuclei which they will interact with. So the force of attraction between different these nuclei and the pi electron will increase. That will reduce the energy of the molecule or increase the stability of the molecule. Now, if you want to summarize this aldol reaction, so what we have done is, if you see the mechanism, the first thing has happened is acid-base reaction, from which OH negative from NOH and H from the one of the aldehyde. Then what happens? Then the nucleophilic addition happens. Okay, so they get condensed. What happens next? Because it was dilute again, H O negative will get H from the dilute NOH. So acid-base reaction again. And after that, what is happening? The elimination. The elimination is happening. So if you remember like this, everything will fall in peace. It is just a story. And now in your mind, you will understand like how things are adding. Now, if you're thinking like so many things have happened, how to revise it, this is a way. In your book, there is also ketol, formation is given. So we can do similar actions. Most of the steps will be common. You'll be able to figure it out like what has happened. So if you know the aldol reaction, this will ketol formation, you can also simply do. Just the region will change and we will see what is the difference. You will get it. So first thing is I will get two ketones, molecules, because I want to do the condensation. I want to join them. So CH3, see the carbonyl carbon, both sides have alkyl group. That's why it is a ketone. It's not an aldehyde. There I was using NOOH, okay, sodium hydroxide. Here I will use barium hydroxide, right? Barium hydroxide. Okay. The formula for it'll be for barium hydroxide. Remember, whenever we are using any base or any acid, the water content will be always there. Okay, so most of the time you have to think of like they are dilute, right? They have water in it. So this is also a base. So that's what the change is. Now you will see everything is similar. So first we will get a ketone. So now I'm joining them. So it will be CH3. This will be having this side CH3, and here it is OH, and here it is CH2, and here is our ketone. Yeah, ketone, ol, we got ketol. Yeah, we will call it ketol. Now what is the next step we do? We remove the water, right? Put a triangle like that, similar thing. So this H will go, and this H, one of the H will go, and it will establish a double bond. So I will get like this, CH3, CH3. This OH is gone and has converted into one H is gone also from here, and this is what we are getting. Okay, so this is the second reaction. Now can you imagine what will be the mechanism? It will be just similar and you will have fun. Let's do one by one so that we repeat it. Aldol reaction is, on our fingertips. Let's do the mechanism. Okay, see here, I will show you one of the ketone molecule. So it is CH3. See, this is double bond, carbonyl, and other CH3. I'm just showing expanded. Okay, now it's a here quiz. Can you tell me where is the alpha carbon? Yeah, this is the alpha carbon. Next to attach to the carbonyl carbon, we can call that carbon as alpha carbon. Where is the alpha hydrogen? These all three are alpha hydrogen. Okay, what are their nature? They are acidic. H positive can be donated. Remember that this is our alpha hydrogen. So it is a repeat which we have done. Okay, it is acidic in nature. Okay, so now the barium hydroxide, right? So that is also like working like sodium hydroxide was working. It is a base, so it will donate OH negative. Yeah, and what they will do, what I will call this reaction, I will call this reaction as acid base reaction. Yeah, so this will be removed, right? This H will be removed. What will happen if H is removed? Carbon will say, okay, H positive is gone. I have to take care of this electron. Remember, there are two electrons here. right? There are two electrons. One was, one was of hydrogen, one was of carbon. So this H positive has gone, nucleus has gone. This electron is still there, so it will come back. The carbon will take it back, and it will become negative. Okay, so acid-base reaction has happened, and what we are getting out of it is CH3, C double bond O, and C negative, right? CH2, I can say. Now, can you tell me what will happen next? See, this has become negative due to this acid-base reaction. So it will look for a nucleus. So it will do a nucleophilic addition from which it will get condensed the other molecule, right? This is the one molecule of ketone. So there was other molecule. We have taken two molecules of ketones. So I will write that down here. So that will be like CH3, C double bond O, and CH3. Okay, so this is the other molecule. This has done the acid reaction. That's why it has become negative. This carbon negative charge will look where is the positive. Is there anything which is electron deficient? Yes, it is. These carbonyl carbons are electron deficient, so that's why they allow nucleophilic addition. So this is what this carbon molecule from this will get attached here. And what is this happening? Let me write it this time fancy. This is what we are calling nucleophilic. Wow, it looks beautiful addition. Yeah, just be a little bit careful when you're doing this. We have to combine this guy here. So I will write down this molecule, CH3C. So this double bond will not be there now because carbon cannot have 5 bonds, right? So if it is trying to do nucleophilic addition, oxygen will take back this electron and become negative. Yeah, so this will be CH3. Now I will attach this part whole. So this CH2 is got attached. Okay, and this I can show it here like that, CH3. Yeah, so this is a ketone. They have condensed, if you see. Now what will happen? Again, barium hydroxide have water also. So HOH, H2O. I'm just writing it like that. So water will do its thing. So this H will go to this because remember we want ketol. So ol is getting formed here. What kind of reaction is this? This is acid-base reaction again. So same repeat which we have done. So this is called acid-base reaction. So now if this is done, we will get CH3, COH, we get a ol. This is CH3 and this is CH2, C double bond O, CH3. So now our ketol is ready. So what we after that, what we will do? We eliminate water, right? So that is what the elimination reaction we will see. So let me do that. So now see what will happen. I will remove water from here. I will heat it up with this triangle. I'm showing that. So now from where it will remove? So this OH will go, right? Eliminated. And then remember, don't remove with the same carbon here, right? So we have to remove H from here, right? From here. So we will remove one H from here. Okay. So only one will be remaining here. And we will get a double bond here. So I will show the result. How it will be? It will be CH3, CH3, CH3. OH is gone. So this CH3 I can just show like that. So this CH3 I'm just showing on the top of it so that I can straighten this out. And we will have a double bond. See, double bond here. Because one H is gone, so only CH will be there here. And this is the double bond, this one and this one. Now you can find out the final result. This is the final product. And can you see double bond, single bond, double bond, double bond, single bond, double bond? So these pi electrons, right? These are the pi electrons. Now they are in conjugation, alternative. So if they are in conjugation, what they will show? They will show resonance. And if they are in resonance, we understood these pi electrons will move through different nuclei. This nuclei, this nucleus of carbon, this nucleus of carbon, this nucleus of carbon, this nucleus of oxygen. So they are talking to different nuclei. So they will, the force of attraction between the nucleus and the pi electron will increase due to resonance because they can delocalize. They are delocalized. They can move around, and due to that, the energy will get down molecule. Every molecule wants to chill. Everyone molecule wants to have lesser and lesser energy. And if the energy is decreased, we have a expression: energy and stability are indirectly proportional. So if we are decreasing the energy, the stability will increase. So the stability of this molecule will increase. So that is why the reason is that H2O is getting removed here, because they know if we do this, okay, if we get a chance of removing this H2O, we will get a structure which will be very stable. And everyone wants to be having a stable state. So this molecule is not a difference. If this resonance is the future, they will see if we can do, or we can create a resonance structure, they will readily eliminate, right? Readily eliminate. So this is the elimination reaction. Yeah. So elimination reaction can happen here. So if you want to revise like what has happened, first, what happened? Acid-base reaction happened. barium hydroxide. That is what the OH negative is coming and alpha hydrogen is getting out. Okay, then what happened? Then a nucleophilic addition happened. Then again acid base reaction from, because we told that barium hydroxide also have water content, so that OH all we got and it got condensed. Then after that what happened? We got a ketone and then we removed the water, so elimination happened. If you note down the steps, right, they are similar to what we have done for aldol. I know these are the holidays time, but I remember this thing. So I'm talking about every video afterwards. You will be thinking like there are too many things to remember. But the thing is, you don't have to. You have to practice. So when you do many reactions, what will happen? You will be able to see the pattern. So the pattern will start to emerge. Like think about even in this video. If you are able to do aldol, you will be able to prepare ketol also. If you know the basics. So remember the story. Remember the mechanism so that you are able to explain what is happening. Yes, there are like things which you just need to remember, which kind of reagent is there, which substrate is there, but that is just a matter of discussion, nothing else. If you think you can just see this page and remember all this, no, that cannot happen. So that has to be discussed, that has to be spoken, so that this will not become your fancy words. Remember, whatever you are remembering in your daily life, this will take only 1 to 2% of that. There are many things in your daily life which you are remembering without any judgment. But here the judgment comes, because there are fancy words: benzene, barium hydroxide, sodium hydroxide, dilute. So we think those are fancy words. But if you keep on using it, keep on discussing it, this will be just a cakewalk. Please understand that. So what we need to do is we need to write down these again and again. First, let's do alone. Put a video, understand everything. If there is any confusion, discuss with someone else. You can ask in the group if you want. Second thing, put understand this video and try to explain what is happening. Okay, just giving a seminar kind of. Try explaining to someone else, and then keep a paper and pen and do it from the start and see where you are getting stuck, what you are not able to remember, and see that part only. Don't revise totally word to word, that will never help. And now you will get comfortable with that, and after that play that video. But whenever I'm saying you, before that, right, you should be able to do what my next step will be in the video. That way you'll be able to master these equations, reactions, like anything. Please believe me, trust me, and you will be able to do it. Best of luck for your exams. Thank you.